Hi ladies and gentlemen, in this video we are going to start with probability in chapter 2 from page 50 to 95. As you have come to realize, we work according to the learning outcomes in the study guides, and today we start with unit 2 on page 17, where we will define the sample space for an experiment. Also, we will define an event. We will distinguish between simple and compound events. And also, we will list the sample space for an experiment. This is the homework for this lecture or this video. Also, you can go and have a look at examples in section 2.1. It means examples 2.1 to 2.7. And these are the exercises that we will provide the solution for them. But if you really want to go and test your knowledge, you can also go and look at the supplementary exercises at the end of chapter 2. This question will not be discussed in class, but if you send me or the tutors your work showing that you tried the exercise, we will help you with the answers. Okay, let's quickly recap what you have done in chapter 1. You look at the concept of population, you look at the concept of sample, and then you look at different sampling techniques and you learn how to do each of these sampling techniques. Also, you looked at exploratory data analysis and descriptive statistics, the various ways you can plot data, the central tendency and dispersion measures that you can use to determine, for example, what is the midpoint of your data, what is the mean or average of data, what is deviation in your data, and how skewed is the data. But from chapter 2, we are taking a sample from population, and for example in chapter 2 we are going to find some probabilities based on this sample that we can use as a part of our inference or our conclusion that we can make about the whole population. In chapter 2, we are just going to introduce the concepts of probability, but the inference part will be discussed in chapter 3 to 5. In section 2.1, we are going to introduce sample spaces and events. Okay, probability as a theory introduced by Kolmogorov in 1933 with 3 axioms, but in fact probability began by Cardano, Pascal and Fermat between the 16th and 17th centuries with solving some problems related to gambling, for example some problems about throwing of dice. But what is the definition of probability? It would refer to a study of randomness and uncertainty, or it gives us a way to quantify or put a numerical value to a situation where multiple possible outcomes may occur, or it's a numerical measure of how likely something is going to happen, but it's important that we use it every day in a formal or informal manner. Let's look at some tangible examples. What is the chance of precipitation today? In this picture, you can see some of these values: 24%, 10%, 9%, or even 0%. We always talk about this, or we always check these numbers in our phone before going out. Or what is the risk, or what is the chance of death from a surgery? It is so important for all of us to know about this before doing any kind of surgery. And also, what is the odds that you will win a lottery? For example, here if you look at this picture, you can see that it's 20 millions to 1. It's a very small probability to win a lottery. Also here you can see other examples. For example, how likely are you going to catch the coronavirus? Or what is the probability that your political party will win during the South African municipal election? Or what is the chance that a volcano will erupt in the next year? Okay, about this one. If you look at how the virus spread over the world and in our country, the probability of catching coronavirus today, it seems, is much less than, for example, a year ago. But now it's interesting because you already know one of the axioms, or even maybe two of them. A probability always lies between 0 and 1. Let's look at this example again. 0%. And the maximum value is 100% for a day. So probability can be expressed as a percent, but it is still between 0 and 1. For example, look at here. 24%. It means 24 over 100, less than 1. 0%, it's 0. 100% is 1. So the minimum value of probability is 0 and the maximum value is 1. So probability is always between 0 and 1. But 0 shows impossibility, and 1 shows certainty. And for example, here we have 1 out of 6. It's not impossible, but it's a small probability. And here we have 4 out of 5 chance, and it's likely, so likely, but it's not certain. Okay, let's continue with other definitions. experiment. A experiment is any action or process whose outcome is subject to uncertainty. For example, tossing a coin, um, conducting a sale call, rolling a die, or drawing a card. Uh, all of us know that if we toss a coin, the outcome is heads or tail. But we don't know which one will happen if we toss a coin. So we don't have any knowledge about this, that which one will happen in advance. So the experiments are subjected to some form of uncertainty or unknown factors. The uncertainty is that you don't know which one you will get. If you toss a coin, you don't know which one will happen, heads or tail. If you roll a die, before rolling a die, we all know that the outcomes are 1, 2, 3, 4, 5 or 6. But if we are going to roll a die, we don't know what is the result or what is the outcome. It can be 1, it can be 2, or it can be 6. We don't know. But what is sample space? Sample space, denoted by S, is the set of all possible outcomes of the experiments. They are known before doing an experiment. So the outcomes are known before doing experiment. For example, about playing a football game, we all know that the outcome is win, lose, or tie. But before finishing a match, we don't know, or from in advance, we don't know what is the result.